I'm going to do another screen recording, and since I don't have a slide and I haven't thought about it very much, this may be a terrible video, in which case I won't post it. But the question I got was, what's happening with pointers? So I want to go back to this. Oops. So I want to go back to the same example, and I'm going to ask you all a question. In the main function, how many bytes are being accessed for automatic memory? It's clearly a weird question, so we haven't talked about it. So yeah, Jarrett, what do you got?
We're accessing
4. So I think that's a very reasonable guess. I'd actually say 8 would be the most reasonable guess. Like there's 2. Yeah, 8. So it turns out the answer is 16. And so there's something that we don't know yet, which is an int is 4 bytes, but pointers also require memory to store. Everything you're doing has an address. And so P1, this is a variable in the same way that if I say int x equals 2, and this is x is at a memory location, and the bits at that memory location represent the number 2. Okay? So now I'm going to go to this one here and say int star p1 equals the address of x. So I'm going to try to use the exact same matching language. P1 is at a memory location, and the bits at that memory represent the address, which is that. Okay, so we've seen these addresses. They're ugly, right? There's something like 0, 7, FFFF, and then you see like some ABCDs and some, I don't know, that's probably too many. I'm overdoing it. But it's something like that. This is bits, and these bits are at the memory location that P1 is pointing to. So pointers themselves take memory. Okay? And this pointer right here, and all pointers, actually take 8 bytes. And the reason they take 8 bytes is because they're trying to store something like this, and this is 8 bytes worth of information. Okay, so if we were to draw memory, we would draw it as, I'm just going to simplify this, and I'm going to say this is 0, here, let me do it up here, 0x7ff, FEDC, so this would be, in my pretend world, this is the address of x, and the value here is the first byte of the integer, and this one is the second byte of the integer at x. Do you guys know dot and VI repeats what you just did? So I'm just pressing dot, and it will do it for me again. And then, if we keep going down, 0x77 FFB, A, ah, 5, 4, 3, 2, 1, 0. And this would be the address of P1, i.e. the location where P1 is storing its data, and its first byte here would be something like 7. I'd have to think about how the bytes encode this stuff, but maybe that has the 7, this has an F, this has an F, and that has a C or something. Okay, so if we had longer addresses, you can imagine that the address is being spread out over these 8 bytes. Wait, I've done this wrong because those are bytes. Sorry. BA987654. There's only 8 bytes. I've drawn 12 bytes. Whoops. And then the address, let's look at a real address. Here's a real address. This address has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm kind of surprised. So it has only 12. Those aren't bytes. They're hexadecimal, so 16 values. So each one is 4 bits, and there's 12. So that means there's 48 bits. And so then the first 8 bits go here. So the first 8 bits would be 7F. The next 8 bits would have FE, EE, EEK, E3, 08. I think I've made some mistakes here, but I hope that I'm being clear on what's going on. There's storage in automatic memory to store the pointer. It takes 8 bytes, and the values at those 8 bytes are actual memory locations. Okay, I see enough people nodding to make me think I didn't do this totally wrong.